In today's note 7374, we are going to graph sine, cosine, and tangent, but we'll start with a little warm up first. So we have a unit circle to the right, and we have this angle theta marked. So if I just draw this triangle here, since that's point AB, this would be side A, and this would be side B. So the first part A, they ask us to find sine of theta plus 360. Theta plus 360 is the same angle as theta. So sine of that angle would be the same as sine of theta, which is B. Go ahead and put your answer to part B in the Edpuzzle now. In your part B, since the angle theta plus 180 just is 180 plus theta, you're going to have the matching triangle over here. Obviously, I didn't draw it very well, but bear with me here. And so when you do sine, this time it should be a negative B since it's heading down from the y-axis. So that should be the only difference there. Let's go ahead and try part C. Part C is cos of 180 minus theta. So 180 minus theta would be this angle here. If I go 180 and I subtract theta, then I'm going to that quadrant 2 angle. So that's where I'm looking. This has the same reference angle theta, which means the same sides, except notice that this one is negative. So your answer to this is going to be negative A. Go ahead and try part D. And obviously in part D, we can use the same triangle that we built here. So your answer to part D should have been B. Now let's take a look at E. So I'm going to go ahead and erase so I can draw again. E is cos of 360 minus theta. 360 minus theta would be this angle here. 360 and back up theta means that I have this triangle with the same reference angle. So again, I have side A and side B. Notice the side B is negative. So your cosine value here should be positive A. Same triangle, give me your answer to F. And in part F, since it's the same triangle, of course, that would be a negative B. Now, this last problem is kind of tough. So I'm going to go ahead and erase everything I have here. I think that's everything. We want to do in this problem sine of 90 minus theta. The way I like to think about this is a couple options. 90 minus theta would be 90, this angle. Take away theta, meaning it would be this component over here. So I could try building a triangle here. The issue, though, is that I don't really like to do that because it's not my typical triangle where it goes to the x-axis. You can do this and it'll work for you. If you can get that to work, that's fine. Another option is I'm going to continue with my same triangle that I had before with sides A and B, but notice how I label the angles. If this angle is theta, then this angle is 90 minus theta. And that's 90 minus theta because those two angles add up to 90. So if I want to do sine of 90 minus theta, which is here, think about it as opposite, which is A, over hypotenuse, which is 1. And that's going to give you an answer A. Kind of tough on this type of problem because you orient yourself in a new angle in the triangle. Our goal for today is to make really nice professional graphs of sine, cos, and tangent. So I'm going to go ahead and walk through the first one with you completely. We're going to make a table first for the function, and then we're going to use it to create the graph. So we're going to set our angle restrictions on the table to go from negative 2 pi to positive 4 pi. The function is f of theta equals sine of theta. So I have my inputs theta, which start at negative 2 pi and end at positive 4 pi. Notice we are all in radians. And then my outputs are f of theta, and I'll have to go find all of those. Now, I think since that's negative 2 pi and that's 4 pi, that I can go 1, 2, 3, 0, 1, 2, 3, 2 pi, and then 1, 2, 3, 4 pi. I think I broke that up evenly. So now each of these are going, 1 pi, 2 pi, 3 pi, 4 pi, going every other block. So then I can go backwards to do negative pi here. And then in between, I'll have the half pi's. So this is pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Or I can go backwards to negative pi over 2, negative 3 pi over 2, etc. Now, we already know sine of 0 is 0 and sine of pi is 0. and 2 pi and 3 pi and 4 pi, etc. We know that all of those are going to give us a 0 value. We also know that sine of pi over 2, that's at the top, is a positive 1. But 3 pi over 2 at the bottom is a negative 1. And I'm going to have this repetitive cyclic value. So I'm just filling in my table here with all of my sine values. Let's see how we use this to make a really nice professional graph. I'm going to go ahead and mark the first one at pi over 2 and the second one at pi. I'm going to go 3 pi over 2 and 2 pi, 5 pi over 2 and 3 pi, 7 pi over 2 and 4 pi. I'm going to go backwards as well, negative pi over 2 and negative pi, and then negative 3 pi over 2 and negative 2 pi. Did I say that all right? I think so. Okay. And then the highest value I'm going to go to is positive 1, and the lowest value I'll go to is negative 1. Let's plot these points. So I have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and I'm going to continue this pattern. Try not to miss any. You should be able to tell if you miss one, because when you go to connect them, it'll be really wonky looking. And then when you connect them, it's just like yesterday's notes where you have to connect them smooth and you kind of curve through. So it looks like this. No sharp corners in your graph here. Nice and smooth all the way through. Looks something like that. This is the function sine of theta. Cosine of theta is very similar. Notice that sine of theta starts on the origin, on the 0, 0. That's a big difference between sine and cosine, and we'll address that at another time. For the sine function, the domain is all real numbers. If you want to write that out in interval notation, you can certainly use negative infinity to positive infinity. Remember that we never include infinities, so that would be parentheses, not brackets. Your range, however, is limited. We go from negative 1 to positive 1. We include both, but we don't have anything outside of that interval. The period. From yesterday, the period is how long this thing goes until it starts to repeat itself. So I have just gone over one full period of this graph. After 2 pi, it starts to repeat itself again and again and again. So the period for this function, cosine as well, is 2 pi. The amplitude is the height from the middle, which is 1, and the midline is y equals 0. Don't forget to put a y equals on that because it is a line. What I would like you guys to do is apply this same technique here and do your graph of cosine on the next page. And you are going to fill out the same values for the angles, but edit the outputs. You're going to plot them and make this a very similar looking graph, and then you're going to identify all the pieces of it. After you finish the cosine graph, I would like you to go down and do the tangent one. When you do the tangent one, again, you're going to use the same angles. F of theta is tan of theta. You're going to run theta from negative 2 pi up to positive 4 pi, and you're going to evaluate to get all those angles. Go ahead and make that table now. And hopefully what you guys saw when you completed your table for tangent was that the only outputs you ever got were 0 and undefined. Well, that's not super helpful. The first thing I want to address is what the undefined look like. All of these undefined outputs are going to graph as vertical asymptotes. So you have a vertical asymptote at negative 3 pi over 2 and at negative pi over 2 and at positive pi over 2, etc. So go ahead and draw in all those vertical asymptotes, and then also plot all your zeros as well. So we have zeros on 0, pi, 2 pi, etc. Plotting all these guys. Well, if that's all the information you have for your graph, then you really don't know what it looks like. So what I recommend doing now is looking where else you can find other values. So maybe we want to go to the pi over 4 angle. We know that tangent of pi over 4 is positive 1. So let's plot that. We know tan of 3 pi over 4 is negative 1, and 5 pi over 4 is positive 1, and 7 pi over 4 is negative 1, etc. So I'm going to use those pi over 4 values to get some more points on this graph. Hopefully I plotted them all right. Still doesn't show you much what you have, but here's the shape of tangent. What's going to happen is you're going to go for each of these sections, you're going to curve up. It kind of looks like that cubic function that we are used to, the x cubed. So it goes through the pi over 4 negative 1 point and then up through the pi over 4 positive 1 point. When I say pi over 4, I just mean one of the pi over 4 types of angles. And you're going to have these same images with each of these sections. Since I stopped there, I'll cut that one off and then I'll go like this. Okay. Oops, I missed the section here. There we go. This is your graph of tangent. Let's talk domain. Your domain is everything except it's not the asymptotes. So it's not pi over 2 or 3 pi over 2 or 5 pi over 2 or 7 pi over 2. How do we write that mathematically to show that we want to exclude the whole thing? To write that mathematically, we start with the first one. We say it's not pi over 2 and multiples of pi after that. And that expression represents pi over 2 plus 1 pi plus 2 pi plus 3 pi, which would give me the 3 pi over 2 and the 5 pi over 2 and the 7 pi, etc. The range for tangent is all real numbers. And the period is not 2 pi. This time it is shorter. It is just pi. Amplitude and midline do not apply because there is no max height for this function. So there is nothing I can do for those.